Analyzer CAM help documentation. Analyzer CAM for AutoCAD was developed as part of the Analyzer family of CAM applications to connect analyzer manufacturing to your CNC machine. It will nest all parts created by analyzer manufacturing and sends all the necessary data to your CNC machine, including label files for your label printer. Generates 3D nesting layouts of your parts in seconds. Fully customizable tool paths with lead in and lead out options. Graphical display of drill bank. Selection of multiple parts lists. Individual selection or deselection of parts. Easy trial of various plate sizes for optimal yield. 4 different machine orientations. Integrated graphic design of label layouts. Supports all AutoCAD versions with autoloader mechanism for plugins 2012 upwards. Supports earlier versions, but require manual installation. Installation. System requirements. AutoCAD 2012 or higher for plug-in autoloader installation. Earlier versions require a manual install through APP, Load and CUI, Load. Installation process. After downloading the setup.exe file, run this file and follow the prompts. Make sure to exit AutoCAD before you start setup. All necessary files will be installed as the current user. Run the setup again for any additional users. The installation software will set up a help link in your Start menu. Read this file before you start drawing cabinets. It is also a tutorial that explains the procedures to get you started immediately. For in-depth information, select the corresponding topics. Now start AutoCAD. Click the Analyzer CAM tab and you should see the following icons. Important. In newer AutoCAD versions, you will see the following pop-up screen when you first click on one of the above Analyzer CNC commands. Make sure you click on Always Load to enable the plugin. Panel Optimizer. Clicking the Panel Optimizer icon will open the following dialog box. If you haven't selected any parts, the corresponding field will show 0. In order to start, you have to click Select Analyzer Parts. That will bring up the following dialog box. The current parts list will be empty. To select parts, click on Add Parts List and the following dialog box will pop up. Now select the job and material you want to optimize. Click on Open, and if you want to combine more of the same material from other jobs, work orders. Just repeat the process and those parts will then be listed in the current parts list as shown below. From here you can select or deselect individual parts that you want to exclude from nesting. To check for oversized parts or maximum required board length, sort parts list by length. Update QTY lets you update the part quantities for each selected part or multi-selection of parts. Once happy with your selection, click on Continue to Optimization to go back to the original dialog box. Now the selected items are shown in the upper part of the dialog box. With plate length and plate width you can now specify the size of the board the parts have to be cut out of. If your parts have a grain direction you want to tick the Allow Part Rotation box. Click Optimize, Nest to create a 3D nesting layout. If you are happy with the layouts, the next step is the post-processor. See next topic. Post-processor. To open the post-processor dialog box, click on this icon. The following dialog box will be displayed. Click on Select Objects to select the plates you want to process to the CNC machine. Now the selected plates will show up on the list box. In the File Name box you can specify the file name for the NC file that will be sent to the CNC machine. When ready, select the Process button to start the post-processor. This process will create a new directory in the specified output directory. It will also write the files that are needed for label printing. A message box will display how many boards have been processed. That's all. You may want to copy the created directory to your CNC machine or server. Path Manager. Path Manager is started by this icon. Tool paths control how a tool operates for a specific task. It can be used for drills as well as router bits. To set up a new tool path, select New Tool Path. The following dialog box will pop up. Fields. Toolpath layer. Enter the layer that Analyzer Manufacturing puts out, i.e. DV_5_1 for 5 mm drills. Toolpath priority. This specifies in which order the tool is applied, basically the picking order. Path description. Describes what the tool path does. Path type. Select between offset pocket and drill. Offset is used for cutting out parts along a specified path. Pocket is used for routing pockets that do not cut all the way through the board. Drill is obviously used to drill holes. Tool compensation. Left. Use this for internal female cuts. Center. Center of router will run along this line. Right. Use this for external male cuts. Tools list box. Shows tools to be used on this path in order of priority. You can specify different tools to be used in the same path. Tool details. Tool. Select the tool to be used for this path. Tool order. Select one for the first tool to be used on this path. Final depth Z level. Specify the final depth of the cut or drill depth. This can be set as an absolute value or a formula to trace a tool depth specified in Analyzer Manufacturing. Example: -0.2 will cut 0.2 mm past the underside of the plate, typically used for final offset cuts. PTDP is a formula used for pockets or drills that works to a specified depth of path dp from the top of the plate pt. The following variables can be used: PT plate top, dp depth of path, UF upper face of plate, number of steps. Specify the number of steps to be used for this cut. First step depth. Use this if your cutter has an upcut part that would chip the top surface if it is not deep enough in the board. If your cutter has an upcut at 6 mm, put a value of 7 into this field. The first step will then be a minimum of 7 mm. Path offset. This is used if you do an offset cut around your board. You will typically specify the first part of the tool path 0.5 mm away from the part edge. The second path cut will do the final cut and will be exact on the line. So specify then 0.0 mm to cut away the 0.5 mm. Path lead-in overlap. It is good practice to have a small overlap of the beginning and end of the tool path. Max step depth for materials. This can be ticked when you have specified different step depth in your tool specification for specific materials. See Tool Manager for more details. It will then override the values in number of steps above. Lead-in. Select between None. Plunge tool to specified depth. Linear. Lead-in path is in a straight line. Arc. Lead-in is in a curved line. Dist. Radius. Enter the length of the linear lead-in path or the radius if you have a curved lead-in. Generally triple the amount for an arc lead-in to get a similar length of a linear lead-in. Angle. This is the angle of a linear lead-in path in comparison to the actual path. For arc lead-ins, this is the angle of the arc. Lead out. Select between None. Plunge tool out of specified depth. Linear. Lead out path is in a straight line. Arc. Lead out is in a curved line. Add tool. This will add the tool values to the current path. Update tool. This is to update a previously selected tool. Delete tool. This is to delete a tool out of the current tool path. Tool Manager. Click this item to start Tool Manager. Click New Tool to set up a new tool to the library. Tool name. Give the tool a meaningful name. Tool type. Select between router or drill. Tool diameter. Enter the exact value. It will be used to calculate tool compensation. Tool max. Depth. This value will be used to limit how deep the tool can dive into the material. Rotation direction. This value specifies the rotation seen from above. Tool parameters. In this section the tool's parameters can be adjusted to various materials. Analyzer CAM will search a part's material name for the specified name in material and will apply custom parameters. If the name cannot be matched, it will use the parameters specified under default. Every tool has to have default parameter values specified. Tool location. This is the tool turret. Match the number with the location in your tool changer and set the tool name that matches the tool specified in the previous section. Use Add to fill all the tools. Use Update every time you change a tool. Drill location. This represents the drill bank of your CNC machine. Drill head offset. This is the position the drill head has to move to have specific drills lowered in the right position. To set up specific drills in the right position of the drill head, select the drill name first. Then the number in the drill bank. The drill position is done by filling the X, Y and Z values. Then use Add to fill the drill bank. Click on. This will create a block on your current drawing showing the position and diameter of the drill specified in drill location. The red cross is the coordinates specified in drill head offset. You can use the above block as an overlay in the nesting drawings if you want to check if drill positions match actual drill holes. Settings. Optimizer defaults. Insertion point. Specifies the coordinates where the first plate will be inserted in the drawing. Plate length, width. Enter the most common board size you use. Plate Y spacing. This is the distance Analyzer CAD puts in between plates when drawn. Plate trim. Enter default value. Plate padding. Enter default value, depending on our lead-in and lead-out settings. Part text height. This is the text height that shows in the center of the part displaying part name. Plate text height. This is the height of the text shown at the bottom left corner of every optimized plate. Optimizer colors. This section uses AutoCAD color codes to be applied to various tool paths and tools. Post-processor settings. Machine file name. Name for the post-processor file specific to our machine. Decimal precision. Number of digits behind decimal point for output in NC files. Min feed rate. Slowest feed rate that will always be applied when a tool goes below the plate top in Z direction. This prevents a tool from entering and staying on the same spot. Min spindle speed. This is the slowest spindle speed that can be selected. Prevents a tool entering a board without turning. Orientation. Select in the drop-down box the 0 point of your machine. File paths plus names. DXT path. This is the path name where Analyzer Manufacturing is saving the parts list files. NC path. This is the path on your PC or server where Analyzer CNC will save the output files. NC folder name. Select in the drop-down menu the format each subfolder should be created. NC file name. This is the default name for the NC file. Apt file name. Default name of intermediate apt file. Settings. Additional parameters. Used to adjust various parameter for display, post-processor and label print. Open label design drawing. This opens a drawing in AutoCAD showing the exact layout of a label with all the text and values that Analyzer CNC can print. Adjust this to your needs and use the following command. Set label layout. Select this layout and it will read it and use it as a template for your label printout. Make sure to save the drawing for future adjustments. Accessories. Click on Accessories. Manual tool paths. This is used to do manual trim cuts to partially nested boards. Path name. Choose tool path with this drop-down box. Only tool paths with a path type of line are shown. Select line to convert to tool path. Click on this button and you will be prompted to select a line. It can be a joint line with directional changes and it will be converted into a polyline and then the tool path applied. Rotate part. Click this button and then select a part on the nesting. The part will be rotated 90 degrees counterclockwise. This differs to the standard rotate command by the fact that the label direction arrow will be adjusted. While the standard rotate command would result in an incorrect label. Re-nest existing parts. Use this feature to grain match parts. Draw fronts. Doors. Arrange your parts so they line up. Then select Custom Group and group them together in matching order. Click on Re-nest. Here you select the parts and plate you want to re-nest. You can select optimization as length or width biased. This will result in different patterns, choose whichever is best. You can also readjust plate length and width. Thank you for watching this tutorial. We hope it has helped you get started with AnalyzerCam.